Good evening, friends. Okay, let us start with Unit 5, which is Turing Machine. Let us see its definition. Turing machine is foundational mathematical model of computation conceived by Alan Turing in 1936. So long way back in 1936, Alan Turing started or conceived this idea of uh, implementing a stored kind of a program. That is, it's a stored program is stored in a memory, and computation is done in the memory. This hypothetical machine is capable of simulating any computer algorithm and is thus considered a model of general purpose computer. And later on, uh, in the name of Alan Turing, we have Turing Award in computer science related field. It's like a Nobel Award in other areas we have, like physics, chemistry. There is Nobel Award. So in computer science, we have award like Turing Award. So how Turing machine looks like? So it has a tape. So this tape is like continuous memory. So it is a continuous memory. And then there is a head. This is a head, which is, you can call it as a read write head. This is read write head. That is, it has a capability to read the input from the tape as well as write something on the tape. And it is driven, this read write head is driven by a transition function. It is driven by, hello? It is driven by transition function. And transition function, you know that it is like going from one state to another state. That is, from Q0 state, you are going to Q1 state. From Q1 state, you are going to another state, Q2. Like this. This is called as a transition function. Or you can call this as a transition logic. This transition logic in Turing machine is represented as like this. That is, it takes the we will study this delta function in the 7 tuple format. So this is the Turing machine. So Turing machine is formally defined by 7 tuple. Like we have 7 tuple push down automata. So it is Q, sigma, tau, delta, Q0, BF. So what exactly these terms are? You know Q, that is, it's a finite set of states. Sigma is finite input alphabets. That is the set of symbols that can be read from the input. Okay, so these are the finite set of symbols. Then tau is the finite set of tape symbols, that is different symbols available on tape. It includes the input symbols, that is sigma, and blank symbols typically represented as B, or it is also represented as this is represented as blank symbol. This is called as blank symbol. And possibly other symbols used by the machine. Okay, so tau that is we have in a PDA is a stack symbol, while as in Turing machine it is called as tape symbol. Now we have a transition function delta. This function defines the machine's behavior. So given a current state and symbol read from the tape, it determines the next state and symbol to write on the tape and the direction to move the tape, head left or right, or no movement, or no movement. So it is represented as like this. That is, it is a combination of q cross tau. That is, it takes the state versus input symbol or tape symbol, and it gives us the state, then again updated input symbol, and also the movement of head. So this is the 3 combinations this delta function gives. Q0 is the initial state and it belongs to Q0 belongs to Q. And we have blank symbol represented as B, or it is also represented as blank like this. And this symbol on the tape to fill the empty spaces on the infinite tape. And F is the set of final or accepting states in a Turing machine. Now, how it is actually, let me show you. For example, you have a tape, and tape is like this, and the first symbol, let's say our input is now 1 0 1, and let's say this is, before this input we have a blank symbol, and after this input we have a blank symbol, indicating that this is input, this is input. Now we have a head, that this is a head, this is a TM head. So now what it is doing, it is reading the input 1. Now what it is doing, reading input 1. Now what it can do, it can update, or it can replace 1 by any other symbol. based on our logic. And then this head can move to the right. Then head can move, number one, it can move to the right or to the left or no movement, that is, it can remain stationary. Now, so this is how it is explained how Turing machine works. That is, it starts in the initial state. So this is the initial state in our, this is, let's say this state is Q0, and it starts into that and reads all input. It reads 1, then 0, then 1, and then comes to blank and then stops. And based on that, it performs some action based on our logic. Now, when with its head on the input, reads the current tape symbol as I told, and based on the transition function, based on the logic, it writes a new symbol, moves left or right or no movement, and switches to a new state or remains in the current state. And the process continues until it reaches a halting state, that is either an accept state or a reject state. Now, let us see the example of implementing a Turing machine. We will see that what language it specifies, Turing machine, what language it accepts in a later part of our lecture. Now let us first understand how actually it works. Now see a problem. Design Turing machine for the following language by considering transition table and diagram. So what is the first problem? So we have to design a Turing machine TM that erases all non-blank symbols on the tape where the sequence of non-blank symbols does not contain any blank symbol B in between. That is what we have to do. We have to remove the non-blank symbol and convert it into blank symbol. TM that erases all non-blank symbols. Erase means what? Converting into blank. So now what will be our input? So let us see the first problem. So input, let us assume that our input is like this. It is stored in tape. And right now our tape contains blank. Then input is 1, then 0, then 1, then blank. Okay, this is input. And what should be our output? Our output expected is that it should remove the non-blank symbols, erase the non-blank symbols. So we have this as a blank symbol. This 1, this is input. This is input. So 1 is erased, so it is converted into blank. 0 is erased, it is converted into blank. Then 1 is erased, it is converted into blank. So this is the output expected. So now what you will do, how will you do this? So now you have an input blank 1 0 1 blank, and your head TM head is this. Okay, this is head. So what head is doing now in this case? Head is reading, it is reading 1. What it has to do now? Replace this 1 by blank. So what is the action expected? Replace 1 by blank. So what will be output after this? So output will be blank, and after replacing 1 by blank, move head to right for the next input. So it is converted blank, 1 is converted into blank. Now our head is at 0 1 and head is at this position. Now it is reading 0. It is reading 0. So what it has to do? It has to now replace 0 by blank and move head to right. Okay, so now what will be our output after this step? So after this step, our output will be blank, blank, 0 is converted into blank, and then 1 in head is here and blank. So again, now it has got 1. And already we have an action for 1 that if it is reading 1, then convert it into blank and move the head to right. So what will be the output after this? So blank, 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 1 is converted into blank, and now our head moves to the next. Now it is reading blank. If it is now got blank, then stop the Turing machine or go to the halt state. Go to halt state. That means it will now stop the Turing machine. So our job is done. That is, Turing machine has converted the non-blank symbols, that is 101, into blank symbols. So now how to represent this with the diagram? So now it is an initial state Q0. It's a start state. Okay. So what we are doing? So when 1 is an input, then convert that into blank and then move the head to the right. So how it is written? And we can remain into the same state because it has to now just read the input either 1 or 0 and convert it into blank. So now we will remain into the same state when 1 is an input. So left part is input and output is that it is shown as arrow. So 1 is converted into blank. So this is 1 is converted into blank, and where we are moving the pointer, we are moving the pointer to the right. So it is shown as R. Similarly, what we are doing for 0? So 0 is an input. So it is converted into blank and move pointer to the right or move head to the right. So we will do all these in a Q0 state. That is, initially it has got 1. So it has converted that into blank. So this is converted into blank. Then again remains into the same state. Now it has got 0. So 0 it has got it. Again it converts into blank. Then it has got 1. Then convert that into blank. Now it has got blank. So as I told you that if it is reading blank, then stop the Turing machine and go to the halt state. So now let us have a halt state here. Halt state. And when now we read the input blank, we don't change blank to anything, so no change is there, so therefore it is not required, and we keep the pointer stationary, that is no movement. So if there is no change, so actually we are keeping blank to blank and no movement of pointer. So this can be represented as blank, no movement. Okay, so if there is no change, if no change, then no need to show output. No need to show output. So this is our Turing machine. Now, how to represent this Turing machine with the transition table? So this is a diagram. Okay, so this is a diagram. Now let us have a transition table. Transition table. So how do you represent transition table? Q cross sigma cross tau. No. What is the delta function? Delta function is q cross tau gives q cross tau cross left right no movement. So that is our transition function. So let us write that q cross tau gives q cross tau cross left right or no movement of pointer. So how it is represented with the table? So it is represented with the table like this. So q here and tau here. So which are our stack symbols? So stack, no, sorry, not stack, tape symbols. So see, this is a tape. This is tape. And our input symbols are blank 1 0. So let us write that. So 1 is one symbol on tape, 0 is also a symbol, and blank is also a symbol. And which is our initial state now? Q0. So what we are doing for one input? So for one input, we are remaining into the same state Q0. 1 is converted into blank and then moving to the right. So how it is represented? Q0 remaining into the same state, 1 is converted into blank and R. And what for 0? We are remaining into the same state Q0, 0 is converted into blank and head is moved to the right. And for blank, what we are doing? We are going into the halt state. So we are going into the halt state. Blank is kept as blank, no change, and moving, no pointer movement N. So we have now halt state. So halt state for 1 we have no action, for 0 no action, for blank also there is no action. So this is the transition table. All of you note down this. So now you have understood how to design Turing machine. Now can we write this transition table in short? So in short, transition table. So same can be written like this. So we have a Q cross tau. Q0 is a state, 1 is input, 0 is input, and blank is input. So for 1, it is remaining into the same state. So we can omit that. So whatever remains constant, we need not show it. So for example, if it is from Q0, it is remaining into the same state Q0. Therefore, I omit Q0 and I just show the change. So change is blank right. So it indicates that I am remaining into the same state. For 0, it is also shown as blank right because it is going into the just converting into blank. And for blank, there is blank is kept as blank. Therefore, no need to show it. So what is a change? Change is that it is going into the halt and no movement of head. And for halt, there is no transition, so dash dash. So this is one way of representing again a transition table. This is also correct. This is also correct. Now, let us see the simulation. Simulation for input. Let us take the input as 1 0 1 1 0. So this input you can represent it on a tape first. First input represent it on tape. Blank 1 0 1 1 0, then blank. And initially your head is like here. This is a head and initially it is in state Q0. So now how it is represented? So you have a delta and initial state is Q0 and your tape is blank 1 0 1 1 0 followed by blank, and initially your head is here. So where it is going? So as per this table, for Q0 input, for Q0 state, for one input convert it into blank 0, convert it into blank and remain into the same state Q0. So our output will be Q0 blank. This one is converted into blank. Remaining input is 0 1 1 0 blank and pointer is here. Then again it is in Q0 state, blank blank, 0 is converted into blank, 1 1 0 blank here. Then again next step it is Q0 blank blank blank, 1 is converted into blank, 1 0 blank. This is the input. Now again into Q0 state, blank, and this one is converted into blank and pointer is moved ahead. Then again this 0 is converted into blank. And pointer now comes to blank. So now for this, as per this transition table, when Q0 is a state and blank is input, goes to the halt state. So now it goes to the halt state. And remaining input is blank, 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 and pointer remains there itself. So this is a simulation of the Turing machine for input this. All of you write down the simulation. Okay. Now let us come to the next problem. Design Turing machine for one's complement. So what is one's complement? One's complement means 1 is converted into 0 and 0 is converted into 1. It's a reverse of it. So what will be input? Let us take the input. Show the input on tape. So our tape is like this, blank. Then input is 1, 0, 1, 1, 0, and then input end is blank. Okay, so this is the input. So what is output expected? Is one's complement. So output expected is that this is converted into blank, 1 is converted into 0, and 0 is converted into 1, 0, 0, 1, and blank. So this is the output. So what is our logic? So logic will be, if this is the input, 1, 0, 1, 1, 0, blank. If when it reads 1, so when input is 1, then write 0 and move pointer to move head right. And when input is 0, then write 1 and move head to right. And when input is blank, then stop or go to halt state. Okay, so this is our logic. Now how to implement this logic? So we have now initial state q0. It's a start state. So we can do this task in just one state. So now when input is 1, so what is our output? Output means what is to write on tape is 0. And what we have to do? We have to move pointer to the right. And when input is 0, we have to write 1 on tape and move pointer to the right. And when to stop or go to the halt state, let us take halt state as H. Okay, this is a halt state. And when input is blank, then no movement of pointer. You keep blank as it is. So this is the diagram. Now how to represent transition table? Now represent it on a transition table. So transition table would be like this. Q cross star. Now what are the tape symbols? Tape symbol, there are 3 tape symbols, that is 0, 1 and blank. And how many states we have? We have 2 states, Q0 and H. So for 0, what Q0 state is doing? It is remaining into the same state and converting 0 into 1 and moving pointer to the right. So we can write like this. So 1 R. It means that it is remaining into the same state. So 1 is converted into 0, move to the right. And for blank, what it is doing? It is just going to the halt state H and no movement of pointer. And in halt state, we have no action for anything. So we are just stopping. Okay, so this is the transition table. Now let us show the simulation. Simulation for input 1 1 0 1 1. Okay, so now you can show that input on a tape first. So blank input is 1 1 0 1 1 and end of the input is blank. Now head is here. This is the start of the head and initial start is in the Q0 state. So we have a delta Q0, input is blank 1 1 0 1 1 blank and head is here. So how it is doing? It is remaining into the same state Q0, blank 1 is converted into 0 and move pointer to the right. So here a pointer. So remaining input is 0 1 1 blank. So that is Q0 blank 0 1 is converted into 0 and move pointer to the right. So it come to the 0 1 1 blank. So now again Q0 blank 0 0 0 is converted into 1, move pointer to the right. Now this 1 will be 0. And this 1 will be converted into 0. And pointer now comes to blank. And for blank, what is our condition? Go to the halt state. So that is H state and input will output will be 0 0 1 0 0 blank, and pointer is here. Okay, so this is the final state and final output. So final output for using this TM is 0 0 1 0 0. So this is the output. Okay, so this is how we can design Turing machine for ones complement. Okay, all of you note it down. Draw the diagram properly, draw the transition table, and also show the simulation. Now let us see the next problem. Now we have seen this problem, first problem we have seen it. Now let us see the second problem, that is design TM to find 2's complement of a binary number. So what is 2's complement? What is 2's complement? So first do 1's complement. First do 1's complement and then add 1 into it. Add 1 to it. Okay, so this is called as 2's complement. So we have already implemented 1's complement and now just we have to add 1 to it. So what will be the input? So let us take the input as binary number 1 0 1 1. Let us take this is our input blank blank. Okay, this is on tape, so you can write that on tape also. This, okay, so this is on tape, and initially and what will be the output? So output will be, first it will do 1's complement. So 1's complement will be 1's complement. It will be 1 is converted into 0, 0 is 1, 1 is 0, 0. And now add 1 to it, that is 1 is added to it. So 0 is converted into 1, 0, 1, 0. So output will be, our output will be blank 0 1 0 1 blank. So this is the output. Now what logic you will apply now? Logic. So first one is that do 1's complement. Okay, so now here we have blank 1 0 1 1 blank. So after this step our output will be blank, that is 0 1 0 0 blank, and our pointer will come here. Now after 1's complement, our head, initially our head will be here, and after 1's complement, the head will move to the right, and it will stop at blank. Now what we have to do, we have to take this head again back. Now take head back. and add 1. Okay, so we have to write a logic to add 1. So what is the logic? So when we get the let us take this logic, that is, if we have 0 1 1 1 and here 0, and if we add 1 to it, so what will be our output? Our output will be 1 plus 1 will be 0, carry 1, 1 plus 1 0, carry 1, 1 plus 1 0, carry 1 1, and then 0. That means 1 is converted into 0 till you get the first 0, and that first 0 will be converted into 1, and whatever remains after that remains the same. For example, if we have the input 1 0 0 1 1 1, if we add 1 to it, so this 1 will be converted into 0, this 1 will be converted into 0, this 1 will be converted into 0, and this first 0 will be converted into 1, and then remaining this 1 0 will be kept as it is. So this logic we have to implement it. So now take the head back, and when input is 1, then convert it into 0, write 0 to it, and move head left को जाना है. And when you get 0, first it is a first 0, then convert that into 1 and stop. So this is the logic that we have to implement. So now let us try to implement it with the diagram. Now initially you are into Q0 state. It's a start state. So what we are doing, it is we are implementing 1's complement here. 1's complement. So that means 1 is converted into 0, moving pointer to the right. 0 is converted into 1, moving pointer to the right, moving head to the right. Now when we get a blank means end of input, then we have to move the pointer to the left, as I told you now. That is at this case. So when we come to the end, then we have to move this pointer to the left, and we have to implement now add logic. Add 1 logic. So what is add 1 logic? That is, you move to the left till you get 1's, and once you get first 0, convert that into 1 and stop. Okay, so now what will be that logic? So if you get a 1, convert that into 0 and go to the left. And when to stop it? So now let us have a stop state as H, that is called a halt state. Okay, it's a stop state. So where to stop it? So when we get first 0, that is 0, then we have to convert that into 1 and no movement, and that is stop. So this is the logic for 2's complement. This is for 2's complement. Entire logic is for 2's complement. Now let us represent it with the help of transition table. Now let us represent it with the help of transition table. So how you will represent with the transition table? That is, you have a Q cross tau, and which are the tape symbols? 0, 1, and blank. And how many states we have? We have Q0 state, Q1 state, and H state, halt state. So what Q0 is doing? Q0 is doing 1's complement. what q1 is doing, it is add 1. Okay, so this distinct states are there because it cannot be done by one state. That is, q0 cannot do both. It cannot do one's complement at the same time add 1 to it. So we need two states. So for q0, for 0, what it is doing, it is converting into 1 and moving pointer to the right. And for 1, it is converting it into 0, moving pointer to the right. And for blank, what it is doing, it is going to the next state, that is doing for addition logic. Because in a blank comes means our one's complement is done. So now for blank, what it is doing, it is moving the pointer, it is going to the state q1. So I have to write q1 here because it is change of state. So q1 and moving pointer to the left. And what q1 is doing, so when it gets 1, it is converting that into 0 and moving pointer to the left. And when it gets 0, write 1 and move to the it goes to the h state, that is h1 and r, or no movement. And for blank q1, it may happen that q1 gets a blank. If q1 gets a blank, see when it will get a blank, that is when everything one's complement is 1, then in that case it will get a blank. For example, let me explain you with the example. For example, we have an input 1 1 1 1. Then what we let us have an input 0 0, all zeros. Let's say 0 0 0 0 is the input. So what will be its one's complement? One's complement will be 1 1 1 1. So here blank is there, here blank is there, here blank is there, here blank is there. Now you are here into q1 state. Now q1 state for 1, what it is doing, it is converting into 0. So what it will do, it will convert this into 0, move pointer to the left. 1 1, then this is blank. Then again this 1 is converted into 0. That is blank 1 1 0 0 blank. So moreover, again this will be converted into 0, this will be converted into 0, and then it will again come into blank. Okay, that is 0 0. Moreover, what is 2's complement of 0? 2's complement of 0 is 0 itself. So now when q1 will get blank, then it will go to the halt state and no movement of pointer. And h state is this. Everyone understood this logic? So here we have to show that what if it gets a blank in q1 state. So here if it gets a blank, then no movement of pointer. So now this is the complete diagram for 2's complement. All of you write down. Now let us try to do the simulation, perform simulation for input 1011. So this is the input. So now how it is shown on tape. So show first on tape blank 1011, end of input is blank and pointer is at initial position. So it starts with delta. So we have a delta, Q0 is a state, input is blank 1011 blank, pointer is here. So now what Q0 is doing, it is doing 1's complement. So Q0 blank 1 is converted into 0, 0, 1, 1 blank, pointer is here. So that means it is going into Q0 blank 0, 1, 1, 1 blank and pointer is at third position. Q0 blank 0, 1, 1 is converted into 0, 1 blank, pointer is at last position. Q0 blank 0, 1, 0, 1 is converted into 0 blank. Now pointer is at blank. So in Q0 state, when it reads a blank, in Q0 state, when it reads a blank, it goes to a Q1 state. So let us go into Q1 state and pointer is moved to the left. So it goes to Q1 state now, Q1 state, and pointer is moved to the left. Now, so pointer is at last position, 0. Now, what Q1 is doing? So when it gets the 0, then it is converting that into 1 and halting it. Okay, so now what Q1 is doing? So Q1 has got 0, so it goes into halt state H blank 0, 1, 0, and this last 0 is converted into 1 blank. So now what is our output? So this is our output. So output is 0, 1, 0, 1. Okay, is it a 2's complement of 1011? Let us see 1011. Its 1's complement is 0, 1, 0, 0. Add 1 to it. So it is 1 0 1 0. So that is our output. So it is matching. So our output is correct. That means this Turing machine is properly working. Now let us come to the next problem. All of you show short simulation also, because it doesn't take too much time, but simulation adds the value to your Turing machine. Okay. Now let us see the next problem. Construct Turing machine that recognizes a language over alphabet 01 such that string ends in 10. So that means the string, it's a language of W belongs to 01, any combination of 01 such that ends in 10. So what is a language that it accepts? Language, minimum language. So minimum language that it accepts is 10 because it is ending in 10. Then next language is 010, 110. That is also part of this language. Now, before 10, we have only one binary number. What if we have now two binary numbers? That is 0010, 0110, 1010, and then finally 1110. So these are the part of the language. So now what logic you will apply now? So you have to have states which will recognize that it ends in 10. Just like we have a finite automata to design the set of strings that ends in 10. So the same number of states will be there for Turing machine. So initially you are into Q0 state. Okay, it's a start state. Let us assume that this is a null state. That is, we have no input now, right now. So if I get 1, then let us come to a next state Q1, which indicates I have got 1. Now if I get 0, then let us come to a Q2 state, which indicates that I have got 1 0. Now after in the Q2 state, if I get end of input, that is blank, and so then I'll come to halt state. It is call this as HE, accept, halt accept. It is accept state. Okay. Let us have this as a final state called as accept state. So now, if in Q0 state, if I get 0, I'll not move ahead because I have to end the string in 10. So for 10, I haven't got anything. So for 0, I'll remain here. For in Q1 state, if I get 1, I'll remain into the same state because after 1, if I get 1, that means I just need 0 to go to the final state. So that means I have got 1. Now in after 10, if I get 0, then I have to again restart to get 10. So if I get 0 in 10 state, I'll come to the null state. indicating that I have to again restart. But in Q0 state, that is after 1 0, if I get 1, then I just need again a 0 to go to the final state. That is 1 0. So now I have got 1. So if I get a 1 in this state, then I'll come to Q1 state. Okay, so that means here if I have my input is, let us take input. So input is blank 0 1 1 0 blank. Initially pointer is here. So if I have got 0 now, so what should be my output for this? My output for this will be HA, that is halt accept. And if the string doesn't end in 1 0, then my output will be HR, that is halt reject. Okay, now for every reading of input, I am moving my pointer to the right and I am not changing any input. Therefore, I have to just move the pointer to the right and input is not changed. So what will be my action now for 0? Just move pointer to the right. For 1, move pointer to the right. For 1 again, move pointer to the right. 0, move pointer to the right. Move head right, right. And here for blank, there is no movement of head, so N. Now for Q0, we have considered 0 moves and 1 move. That is Q0 is over now. For Q1, we have considered 0 move and 1 move. Q1 is over. For Q2 also, we have considered 1 move and 0 move. So now this PDA is correct. Sorry, this TM is with the H8 is correct. Now what will be the reject? So reject will be, let us take a state HR, which is a reject state. So if in Q0 state, if I get a blank, then it will reject because it has not got 1 0. In Q1 state, if I get a blank, that will also reject. In that's it. So it is the reject state added. Okay, so this is the TM finally. So now transition table. So let us show the transition table. Q cross tau. So which are our states? Q0, Q1, Q2, then HA and HR. HA is for accept and HR is for reject. And which are our input symbols? Tape symbols are 0, 1 and blank. So what Q0 is doing, what is Q0 is indicating in this case? Q0 state is indicating I have no null in, I have no input, null. Q1 indicating that out of 1 0 I have 1. Q2 state is indicating out of 1 0 I have 1 0. That is, and after Q2 1 0 end, if I get the blank, then I go to the accept. So Q0, when it gets 0, so it remains into the same state because it hasn't got 1. So just moving the pointer to the right. If it gets 1, then it goes to Q1 state and move pointer to the right. And in Q0 state, that is after null, nothing, if I get a blank, then it goes to HR state, that is reject state, no movement of the pointer. In Q1 state, if I get 1, I'll remain into the same state because I got 1. So I'll go to the right. So in Q1 state, if I get 1, I'll remain into the same state and go to the right. Sorry. In Q1 state, if I get 1, I'll go to the right. And if I get 0, I'll go to the Q2 state and go to the right. And if I get blank, that is I haven't got ending 1 0, and if I get a blank, then it will go to the reject state. In Q2 state, after 1 0, if I get 0, then I'll come to Q0 state. Q0 state, move to the right. And after 1 0, if I get 1, I'll come to the Q1 state, move to the right. And if it gets a blank in after 1 0, that means it is ending in 1 0, then it is accept state, HAN. So HA is not having any action. So these are the state transition diagram. All of you note down. Now let us show the simulation. Show the simulation. Show simulation for input. Let us show two inputs, that is that ends in 1 0 and that does not end in 1 0. Let us take first input as 0 0 0 1 1 0. It is ending in 1 0, so it should accept it. And another input let us take which is not ending in 1 0. Let us take our input is 1 0 0. So this should reject. Now let us work it out, the Turing machine, whether it is really doing the job. So now we have a delta Q0. Input is now, this is a blank, this is blank, this is blank, this is blank. So we have blank 0 1 1 0 blank, and here this is a pointer. So what Q0 is doing for 0 input? See here. Q0 for 0 input is that just moving pointer to the right and remaining into the same state Q0. So that means it is Q0 blank 0 1 1 0 blank and moving pointer to the right, that is to the 1. Now what is Q0 for 1? It is going into the Q1 state and moving pointer to the right. So that is, it is going into Q1 state blank 0 1 1 0 blank. So pointer is coming to the 1. Now what is Q1 for 1 is doing? Q1 for 1 is doing just moving the pointer to the right and remaining into the same state. Q1 blank 0 1 1 0 blank and moving pointer to the right, that is 0. And now what Q1 is doing for input 0? So for 0 it is going into the Q2 state and moving pointer to the right. So that is, it is going to the Q2 state blank 0 1 1 0 blank and pointer is coming to the blank. And now what Q2 is doing for blank input? So when Q2 has a got blank input, then it is going into the accept state and stopping the Turing machine. So it goes to the HA accept state and 0 1 1 0 blank and stopped here. So that means here it has got to the accept state. So therefore string 0 1 1 0 is accepted. Now let us work it out another string which is 100. So we have delta Q0 blank 100 blank and pointer is here. So now where it will move? Q0 on 1. So Q0 on 1, it is going to the Q1 and going to the right. So Q1 100 blank, that is moving pointer to the right, so 0. So now Q1 on 0, what is doing on Q1 on 0? Q1 on 0 going to Q2 and to the right. So Q2 state blank 100 blank and pointer come to the third input, that is 0. Now what is Q2 doing for 0? Q2 for 0, it is again coming back to the Q0 state and moving pointer to the right. So that means it is coming to the Q0 state blank 100 blank and pointer is to the right, that is to the blank. And what is Q0 is doing for blank input? It is reject, HRN. Okay, so that means it is going to the HR, that is reject 100 blank and pointer is here. So that means it is, since it is into HR state, therefore string 100 is not accepted. Getting a point? So this is how you have to do the simulation. So show the simulation for two inputs. One is accept input and another is a reject input. Now let us take the third problem, next problem. Construct a Turing machine to accept a language over 01 containing the substring 001. Now here it has to be substring, not ending with 001, but substring 001. So what is the language it accepts? So the minimum language it accepts is 001. Another language is 0001. 1 001, 0010, 0011, so and so forth. So this is the language that it should contain. String should contain 001. So we can draw its finite automata. So what will be the logic? So let us take input on the tape. So we have a blank and let us take it as 1 0 0 1 1 blank. So you are reading the input 1, go to the right and try to recognize that you get a pattern 001. And once you get the pattern 001 and whatever is the input, consume it, and when blank comes, go to the accept. So how we can design its finite automata then? Q0 is a start state. It represents null. That is nothing. So if I get 0, I come to Q1 state, indicating I got 0. If again I get 0, I come to Q2 state, indicating I got 0 0. And if I get 1 in this state, then I come to Q3 state, indicating 0 0 1. और इसके बाद मेरा कुछ भी आ जाए, 0 आ जाए, 1 आ जाए, कुछ भी आ जाए, तो मुझे वो एक्सेप्ट करना है. So here if I can remain into the same state now. So now for 0 input I am just moving ahead to the right. For 0 movement, read right. For 1 also right. 0 input, moving pointer to the right. 1 input, moving pointer to the right. And after Q3 state, if I get a blank input, then no movement and go to the accept, HA, halt accept. It's a final state. Now अभी let's say मुझे Q0 state में 1 आता है, तो मेरा कुछ भी इनपुट आगे नहीं बढ़ेगा क्योंकि मुझे 0 1 1 चाहिए मिनिमम. एक्सेप्ट करने के लिए। तो मेरा 1 इनपुट आता है तो आई रिमेन इनटू द सेम स्टेट, जस्ट मूव टू द राइट। Q1 स्टेट में 0 के बाद अगर मुझे 1 आता है तो मुझे अगेन पूरा 001 लेना पड़ेगा। तो इफ आई गेट a 1, I'll again come to the Q0 state, indicating I got nothing, because I have to again restart to get 001. अब 00 के बाद लेट्स से 0 आता है, दैट मीन्स 00 के बाद 0 आता है, तो मेरे पास 20 ऑलरेडी अवेलेबल है, मुझे सिर्फ 1 चाहिए टू गो टू फाइनल स्टेट। So that means if I get 0, I'll remain into the same state. Right. Now, what is the condition for rejection now? To reject the string, that is, we have a HR state, which is a reject state. That is, if I haven't got 001 substring, then I have to reject that string. That means if in a Q0 state, if I get blank as input, then reject it. In Q1 state, if I get blank input, then also reject it. And in Q2 state, if I get a blank input, also reject it. Because Q0 state indicates out of 001, I haven't got anything. Q1 state indicate that out of 001, I got 0. And Q2 state indicate out of 001, I got 00. And Q3 is the only state which indicates that I have got 001. तो उसके बाद अगर ब्लैंक आता है तो एक्सेप्ट कर लेंगे, और उसके पहले के स्टेट में अगर ब्लैंक आता है तो उसे रिजेक्ट करना पड़ेगा। So this is the final Turing machine. So now all of you draw its transition table. Now I leave up to you. Show the transition table. So transition table will be like this. That is, you have a Q cross sigma, sorry, Q cross tau. So which are the inputs? Tape symbols are 0, 1 and blank. 0, 1, blank. And which are the states? Q0, Q1, Q2, and Q3. And finally, we have HA and HR for accept and reject. Q0 indicating a state null, that is nothing of 001. Q1 indicating out of 001, 0. Q2 indicating out of 001, 00. And Q3 indicating out of 001, 001. It has got it. तो 0 को क्या हो रहा है, ये Q1 को जा रहा है, going to the right. For 1 it is remaining into the same state, just moving to the right. And अगर blank आ जाता है Q0 में तो reject करना पड़ेगा HR. 0 state में अगर 0 आता है तो going into Q2 state, moving to the right. अगर इस स्टेट में 1 आता है तो फिर से मुझे 0 से स्टार्ट करना पड़ेगा, इसलिए Q0 राइट। और इस स्टेट में Q1 में अगर मेरा ब्लैंक आ जाता है तो मेरा 001 मुझे मिला ही नहीं, तो रिजेक्ट। तो Q2 स्टेट में 1 आता है तो Q3 स्टेट में जाएंगे क्योंकि मुझे 001 आ गया है, और Q2 स्टेट में 0 आता है तो 001 का 00 मेरे पास है, तो आई विल रिमेन इनटू द सेम स्टेट। बट Q2 स्टेट में अगर ब्लैंक आ जाता है तो 001 मिला नहीं, इसलिए रिजेक्ट। और Q3 स्टेट अभी ये फाइनल स्टेट जैसा ही है क्योंकि उसमें 001 आ गया है, मिल गया है, सबस्ट्रिंग है, तो कुछ भी आ जाए, 0 आ जाता है हम राइट में जाएंगे, 1 आ जाता है हम राइट में जाएंगे, एंड ब्लैंक आता है तो हम एक्सेप्ट की तरफ जाएंगे। या फिर आप ऐसे भी कर सकते हैं क्योंकि आगे का इनपुट स्कैन करने की जरूरत ही नहीं है क्योंकि हम फाइनल स्टेट में ऑलरेडी आ गए, तो कुछ भी इसके बाद इनपुट आ जाए, 0 आ गया तो भी हम एक्सेप्ट में जाएंगे, HA नो मूवमेंट, 1 हो गया तो एक्सेप्ट HA नो मूवमेंट, और ब्लैंक भी आ गया तो भी HA नो मूवमेंट। आगे का इनपुट स्कैन करने की जरूरत ही नहीं है। तो अगर आपने ये भी मूव यहां से हटा दिया, फॉर एग्जाम्पल ये मूव, सॉरी, 0 टू द राइट, 1 टू द राइट, तो मैंने यहाँ पे लेट्स से ये मूव्स जो है ये आपने हटा दिए यहां से और यहाँ पे डाल दिया उसको, दैट इज 0 टू द नो मूवमेंट, 1 टू द नो मूवमेंट, तो भी इट इज एक्सेप्टेड बिकॉज उसके बाद स्कैन करना ही नहीं है। तो एनीवे दिस इज ऑल्सो करेक्ट, this is also correct because you are consuming the entire input, and this is also correct because you already got 001, then why to waste the computer processing, we can stop there. So efficient ये है, efficient ये ज्यादा efficient है, while as this is that you are as per the logic going to the end, ठीक है। तो देखिए आपको कैसे ट्यूरिंग मशीन दिखाना है, तो दोनों भी इट इज एक्सेप्टेड। Now show the simulation. Show simulation for one accepting and one rejecting. Okay, let us take the first input. Our input is 1 0 0 1, and let us take the second input 1 1 1 0 1. So let us take a simulation. So you start in delta Q0 blank 1 0 0 1 blank, initially pointer is here. So show it all the steps, show all the simulation. Similarly for next input delta Q0 blank 1101 blank, pointer is here. Also show where it goes and show all the moves. Okay, now let us come to the next problem. Construct a Turing machine for R is equal to AB A star B. मतलब क्या कि the string should start with AB followed by any number of A's and end in B. It's like a regular expression written for regular language. So we have to design Turing machine for that. So what will be our language? So L will be, so the minimum language will be A, B, B. This is the minimum language. What will be the next language? A, B, A, B. What will be the next language? AB, AA, D. What will be the third language? A, B, A, B, so and so forth. तो हमें क्या करना पड़ेगा कि we will have to have a state which will indicate that I got A, I got B, and then ending with B. So let us start with initial state Q0. So this Q0 state indicate nothing. म्हणजे ए बी ए का कुछ भी नहीं मिला है क्योंकि इट्स इनिशियल स्टेट, सो इट्स स्टार्ट स्टेट. If it gets A, it means that move to the again pointer to the right, head. We are coming into the Q1 state. What does it indicate? It indicates that I got A. In Q1 state, if I get B, then move pointer to the right and come to Q2 state, indicating that I got AB. अब इसके बाद मुझे कितने A's मिलते हैं? I'll remain into the same state. A, move to the right. Now in Q2 state, if I get a B, I'll move to the right and come to Q3 state, which indicates the state of AB, A star, B, indicating that it started with AB and now ending B. और इसके बाद मुझे अगर blank मिलता है, with no movement of the pointer, I'll come to the halt accept. It's a final state. अब मेरे एक और स्टेट रहेगी कॉल्ड एज रिजेक्ट स्टेट, HR. क्योंकि अगर मुझे ये नहीं मिला पैटर्न ए बी ए स्टार ए पैटर्न नहीं मिला, बी फॉलोड बाय बी, तो मुझे उसे रिजेक्ट करना पड़ेगा. तो now if in Q0 state, if I get a blank or even if I get B, that means the string is starting with B, वो रिजेक्ट हो जाएगी. So if I get a blank, then no movement, and at the same time if I get B, also no movement, because वो रिजेक्ट है, क्योंकि वो स्ट्रिंग B से स्टार्ट हो रही है. Now in Q1 state, if I get A, मतलब क्या हो गया कि वो स्ट्रिंग AA से स्टार्ट हो रही है, तो वो भी रिजेक्ट हो जाएगी. That means if I get A, then no movement and go to the reject, and at the same time if I get blank here, also reject. अब इसमें तो हो गया, Q2 स्टेट का A स्टार हो रहा है, उसमें A का कोई प्रॉब्लम नहीं, B का प्रॉब्लम नहीं है. ओके, सो दिस वी गॉट. नाउ Q3 स्टेट में अगर मुझे B मिला तो नहीं सॉरी, A मिला और B मिला तो क्या होगा? फॉर एग्जाम्पल A B A स्टार B, इट शुड एंड विद B. तो मेरे पास ऑलरेडी B मिलके आया है, तो B अगर आता है इसमें, इसके बाद B के बाद अगर फिर से B आता है, तो दिस स्ट्रिंग विल बी रिजेक्टेड. Okay, so here if I get a B in this state, then this string should be rejected. अगर मुझे यहाँ पे A आता है, मतलब A B A स्टार B के बाद A आता है, then also it has to be rejected, because it is containing the string of this kind. That is, it should have only the लास्ट में A की B चाहिए, तो बीच में B नहीं चलेगा. म्हणजे B occurs only twice. मतलब स्टार्ट में एक बार ए बी, मतलब यहां पे बी आ रहा है, और उसके बाद एंड में बी आ रहा है, उसके पहले फिर बाद में यहाँ बी आ नहीं रहा है, तो यहाँ पे बी ले लिया, तो एंड में बी करने के लिए बी चाहिए, तो वो भी स्ट्रिंग रिजेक्ट हो जाएगी. सो इफ आई गेट ए और बी इन दिस स्टेट, then it has to be rejected. So this is how this is the Turing machine. This is indicating AB A star. This is AB A star, and then by taking B, it is giving AB A star B. Now all of you show the transition table. अब इसके बाद transition table, you have to draw it. Transition table. It is Q cross tau. So which are the tape symbols? Is 0. No, 0 नहीं, sorry, AB. AB or blank. So let us take this A, B, blank. Okay, and which are the states? Q0 state, Q1, Q2, Q3, and then finally the accept HA and HR. So we have HA accept state and HR, it's a halt reject state. तो Q0 क्या इंडिकेट कर रहा है? इट इंडिकेटिंग आई हैव नो इनपुट नल, मतलब ए बी के स्ट्रिंग में से Q0 स्टार्ट हुआ तो कुछ भी नहीं है हमारे पास. Q1 indicating that it has got A. Q1 indicates that out of AB A star B, तो Q1 इंडिकेट कर रहा है मुझे A मिला है. Q2 इंडिकेट कर रहा है कि आई हैव गॉट AB, और Q2 में हमने A नंबर ऑफ A's ले रहे हैं तो A स्टार ऑल्सो इट इज इंडिकेटिंग, एंड Q3 B के बाद मिल रहा है तो AB A स्टार B इंडिकेट कर रहा है. तो अभी Q0 में अगर मुझे A मिला तो मुझे कहाँ जाना है? Q1 स्टेट में जाना है. और राइट, B मिला मतलब मुझे रिजेक्ट कर देना है, HRN, और ब्लैंक मिला तो मुझे रिजेक्ट कर देना है. Q1 स्टेट में मुझे B मिला तो मुझे Q2 को जाना है राइट में, और A मिला तो मुझे रिजेक्ट कर देना है क्योंकि वो स्ट्रिंग AA हो जाएगी. एंड इफ आई गेट अ ब्लैंक मतलब वो रिजेक्ट करना है. और इसमें A मिला तो मुझे सेम ही स्टेट में रहना है Q2, जस्ट आई हैव टू गो टू द राइट, इट इंडिकेट्स A स्टार. इसके बाद B मिला तो मुझे Q3 स्टेट में जाना है और राइट में जाना है. इस स्टेट में ब्लैंक मिला तो आई हैव टू रिजेक्ट इट, HRN. वो दिखाया कि मैंने Q2 स्टेट में ब्लैंक नहीं दिखा है तो वो दिखाना पड़ेगा. तो यहाँ पे if I get blank here, then reject it, कि वो भी जरूरी है. So now here हो गया. Q3 स्टेट में मुझे ए और बी कुछ भी मिला तो मुझे रिजेक्ट कर देना है। अगर ब्लैंक मिला Q3 स्टेट में, देन आई हैव टू एक्सेप्ट इट एंड देन दिस इज द फाइनल स्टेट, एक्सेप्ट स्टेट। एच ए का कुछ नहीं करना है, एच आर का भी कुछ नहीं करना है। सो दिस इज योर ट्रांजिशन टेबल। All of you show the transition table. Now also show the simulation for one accepting and one rejecting string. Accepting and rejecting string. So let us take first is AB, AB, it's acceptable, it has to accept it. And second is that it is starting with AB, AB, and then it has something called as B. Then it should reject it. Okay, so show it with the help of transition function delta Q0. So input is blank, AB, AB, blank, and pointer is here. So what is Q0 for A doing? It is going to the Q1 state and moving pointer to the right. AB, so here it is pointer AB blank. Now what Q1 is doing for B, it is going to Q2 state. A, Q2, B, and moving pointer to the right. And what Q2 is doing for A, it is remaining into the same state Q2, just consuming A blank, A, B, A, B blank, moving pointer to the right. And what is Q2 doing for B? It is going to Q3 state. So Q3 state blank, A, B, A, B blank. And Q3 state, what it is doing for blank? Q3 state for blank, it is going to the halt accept. It is going to the HA blank, A, B, A, B blank, and no movement here. So it is accept. Now for the next input, show for next input. Okay, so I'll leave it up to you. Now let us come to the next problem. Design Turing machine that accepts all strings over 1 0 with even number of zeros and even number of ones. We have designed finite automata for such problems. Let us see how we can design Turing machine. So let us first assume that null string or empty string is even. Let us first assume that we are assuming that nothing means even. So here what will be the language L? What we have to accept? We have to accept even number of zeros and even number of ones. So even zeros means nothing zeros and nothing ones means null. Null is also part of this language. Now we need to have even zeros. Let us take some zeros and no ones. So that is 0 0 is also part of this. 1 1 is also part of this, because in 0 0 two zeros are there, and so that indicates even zeros, and nothing ones means that indicate even ones. Now for 4 length string, our accepted string will be 0 0 1 1 or 1 1 0 0 or 0 1 0 1 1 0 1 0, or it could be even 1 0 0 1 or 0 1 1 0, so and so forth. So this indicates the acceptable even number of zeros and even number of ones. So let us have now design it, what logic we will apply. So if we have now consider even and odd situation, so we have 4 combinations. So since 2 are there, so we have 4 combinations. So which 4 combinations are there? So the first combination is even even. Second combination is even odd. Third combination is odd even. And the fourth combination is odd odd. Out of this combination we have to accept. So let us represent by these 4 states. So Q0 is the initial state. So in this state, right now we have nothing, null. And we have assumed that when nothing is there, null, string, empty, then it is even. So here nothing is there. So in this case, 0 is also even and 1 is also even. Now let us have one more state in which, let us take it as a Q1 state in which 0 is even and 1 is odd. Let us have one more state in which, let us take this as a Q2 state in which 0 is odd and 1 is even. And let us take one more state called as Q3, in which 0 is odd and ones are also odd. So in the initial state, right now we have nothing, so null is there. Let's say now we have an input, and input is now considering 0. So what does it mean? It means that 0 is now odd because number of zeros are 1. So number of zeros are odd. And while as 1 is nothing, and that is even. So when I get 0, means here 0 is now odd and 1 is even. So which state is indicating 0 is odd and 1 is even? Q2 state. So when I get 0, I'll come to this state and move pointer to the right. Now in the Q0 state, if I get 1, so 1 will become odd and 0 will remain as even. So which indicate that it's a Q1 state. So if I get 1 in this state, then I'll move pointer to the right and come to the state that 0 is even and 1 is odd. Now in the Q2 state, right now 0 is odd. If I get one more 0, then 0 will become even. That is 0 will be even and 1 as it is in even. So that means we will come to the Q0 state. That is, if I get 0, then I'll move to the right. Similarly, in Q1 state, if I get 1 again, so 1 will become even and 0 will not change because we haven't got 0. So that means if I get 1, then I'll move to the right and come to even state. Now let us take in a Q1 state, if I get 0, so what will happen? So 0 will become odd and 1 is odd previously. That means when I get 0, then I'll come to the state that is 0 will become odd. Now in the Q1 state, if I get, I'm sorry, in Q2 state, if I get 1, then what will happen? 0 is odd and 1 will also become odd. That is, if I get 1, then I'll come to the 0 is odd and 1 is also odd. And now in odd state again, Q3, if I get 0, in Q3 state if I get 0, then 0 will become even. That means I'll come here. When I get 0, I'll move to the right. And in Q3 state, if I get 1, then 1 will become even. So that is this state. Now what will be the accepting state? Accepting state is that our string should be, zeros should be even and 1 should be even. That means अगर Q0 state में मुझे blank मिलता है, if I get a blank, then I will come to the halt accept state. क्योंकि Q0 में हमें even zeros है और even ones है, उसके बाद स्ट्रिंग खत्म हो गई तो मतलब एक्सेप्टेड, और बाकी के स्टेट में अगर स्ट्रिंग खत्म होती है then we will come to the reject state. That means if my string is terminating in Q2, that is Q2 के बाद मुझे blank मिला, then rejected. Q3 के स्टेट में मुझे blank मिला तो rejected, and Q1 के स्टेट में मुझे blank मिला, then also rejected. So this is the Turing machine for even number of zeros and even number of ones. अगर आपको पूछा गया कि ट्यूरिंग मशीन फॉर इट शुड एक्सेप्ट ऑड नंबर ऑफ जीरोस एंड ऑड नंबर ऑफ वंस, तो कहां पे आपकी एक्सेप्ट स्टेट होगी? Q3 के बाद अगर मुझे ब्लैंक मिलता है देन इट इज एक्सेप्ट स्टेट, बाकी का सब के और बाकी के स्टेट से ब्लैंक मिला तो रिजेक्ट स्टेट. जस्ट चेंज फॉर दैट. Everybody understood it? Okay, so after this what you have to do? You have to do as a homework, that is draw transition table. Okay, so a transition table of this kind, you have to draw it, and then you have to simulate it. Simulate For two strings, number one is accepting. Let us take the accepting string as 0 1 0 1. Now this is accepting string. And let us take one rejecting string, that is 0 1 0 1 1. Okay, so here do the simulation for this. I hope that you have understood this Turing machine concept. So in the next lecture, we will study some more related problems of Turing machine. I'll share you the whatever is completed till the point, and you practice this in your notebook. Okay, so thank you all of you. We will stop here.